Alright guys, welcome to the third video, and I'm going to continue where we left off with the 7.3 examples. What is the name, and remember name is determined by the number of sides, of a polygon that has 9 diagonals? This time we know the total diagonals, so we have to work backwards. And I know we did an example before that had 9, but if we had to show the work algebraically. The total number of diagonals we discovered earlier was n times n minus 3 over 2. But now that equals 9. So if we had to prove this with algebra, I would multiply both sides by 2 and get n times n minus 3 equals 18. I would distribute the n squared minus 3n equals 18. And this now looks like something that could be factored. So we'd have n squared minus 3n minus 18 equals 0. And if we factored that, the two numbers would be n minus 6 and n plus 3. So two possible answers would be positive 6 and negative 3. But because we're talking about number of sides, the negative 3 doesn't make sense. So we have 6 sides, so the actual answer for the name would be a hexagon. The next example. The sum of the measures of 4 interior angles of a hexagon is 500 degrees. Might as well continue with the hexagon theme. Let me draw one. Not the best, but it'll do. This is saying that 4 of the interior angles together already measure 500 degrees. So maybe let's say that these 4 angles all together are 500 degrees. If we keep going on the problem, it says the measure of the 6th angle is 4 times as big as the 5th. So if we call this the 5th angle and this the 6th, I would represent the 5th angle by x and the 6th angle 4 times as large as 4x. So if we want to find the measure of the 6th angle, we need to continue with a theme we've been talking about with interior angles. To find the total interior angles, we have n minus 2 times 180. But now n is really 6, excuse me there, I'm going to make that 6 minus 2 times 180, because we have 6 sides, 4 times 180, so we have 720 total degrees. So if we're going to make an equation to find my 6th angle, we would have the 500 degrees out of the 4 angles, plus the 5th angle, plus the 6th angle, has to equal 720 total degrees. So that would be 5x equals, let's see, 720 minus 500 should be 220. And if we take 220 and divide that by 5, we would get that x equals 44. So if I wanted to find the measure of the 6th angle, that's really 4 times 44. So my actual answer would be 176 degrees for the 6th angle. Now, section 7.4 has really one only equation in it that does relate to previous things we've been talking about. Before we get into this equation, though, I want to quickly define what a regular polygon is. If you ever see me say that word in class or in this video, it means that the shape is both equilateral and equiangular. So it's kind of nice. All sides and all angles would be congruent if you see the word regular. And also, if you see the word regular, these little formulas here are going to apply. If you picture it, we learned before that the measure and the sum of all exterior angles is 360 degrees. So if you have a figure like a regular triangle or an equilateral triangle, if we wanted to find the measure of each of these exterior angles as we did on a previous video, it would make sense to say that we would take 360 and divide that by my 3 equal angles to find what each of these exterior angles is going to be. And then if we know what each exterior angle is, we could figure out what each interior angle is as well. And so the reason I wrote both of these is it makes sense in either context. If you take the total degrees divided by the number of sides, you're going to get each exterior angle. If you take 360 divided by each exterior angle, you're going to get the number of sides. It works both ways, but this idea only works if you have a regular polygon. Please don't forget that. Let's apply this idea. Find the measure of an exterior and interior angle of an equal angular dodecagon. Now, if you see the word equal angular, that does imply equilateral, so that really also does imply the word regular. Dodecagon, as we've seen multiple times, means 12 sides. So if we want to find the measure of an interior and an exterior angle, I would say because the figure is regular, it would make the most sense to take 360 total degrees and divide that by the number of sides. If you take 360 divided by 12, you get that to be 30, which means in your figure, I don't know exactly, well, 12-sided figure, I don't want to draw all of that, but that means that each of your exterior angles is 30 degrees. So what's a quick way that we could find an interior angle? Well, remember, an exterior and interior angle are supplementary. So that means that each interior angle would have to be 150 degrees. So this little nice formula for regular polygons helped me find that each exterior angle has to be 30 degrees because remember, all the angles are the same because it's regular. And because of the supplementary relationship, each exterior angle would be 150 degrees in this case. The theme continues in number 2. Find the number of sides, so you're trying to find n, that has an equal angular, which again really implies equilateral or regular, polygon, if each of its exterior angles is 2 degrees, pretty small. Well, because it's regular, if I take 360 total exterior degrees and then divide that by 2 exterior degrees, I would get that to be 180. Now remember, what you really found here was the number of sides, because if you look back, if you take 360 divided by each exterior angle, you get the number of sides. So this has 180 sides. So what do we call a figure? Well, if you remember from a previous video, it's really called a 180 gon. Find the number of sides a regular polygon has if each of its angles is 162. When it sees angles, remember, assume that we're talking about interior. Here's the quickest way to solve this problem, in my opinion. Remember, if you have a polygon, I didn't draw the whole thing, but remember that if you have that the interior angle is 162, you can quickly find that the exterior angle is the supplement of 162. So if I drew 162 degrees, this angle would have to be 180 minus 162, which would get you a measure of 18. So that means in your figure, every exterior angle is 18 degrees. So if you want to quickly find the number of sides because it's a regular polygon, you could take 360 total exterior angle measurement divided by each being 18 degrees. And if you do that, you would get 20. This would equal 20, so you would have 20 sides, which means you have a 20gon. The measure of an exterior angle of a regular polygon is twice that of an interior. Now, I'm sorry that I'm being lazy and only drawing part of a polygon, but I'm just trying to make a point here. Every vertex has an interior and exterior angle. So in this case, so the measure of an exterior angle is twice that of an interior. So if we call the interior angle x, the exterior angle has to be 2x. So we know nothing else in this problem except that these are supplementary. So if we started there and said that those two angles are sup, we would get 3x equals 180, so we would get that x equals 60 degrees, which means that each interior angle is 60 and each exterior angle is 120. We're not done though, because it asks again for the name, so we're really trying to find n, or the number of sides. I would say the fastest way is we do know again what each exterior angle is in a regular polygon. So if we took 360 total degrees, divided that by 120, which is each exterior angle, we would get 3, which implies we have 3 sides, which means that the name of the figure would have to be a triangle, but in this case specifically, I would probably say an equilateral. triangle. Last but not least, one more example. The measure of an interior angle of a regular polygon is 36 less than 2 times the measure of the exterior angle. What is the name? What I'd like you to do is keep in mind that number 5 is very similar to number 4. I would like you to please try number 5 first on your own. Please pause your video at this time, and I'll be back with my work. So please pause now. All right, guys, so to check back in with you, I knew if I needed the name of the polygon, I needed n. But first, all I knew was that the interior and exterior angle were supplementary. So I called the exterior angle x. In the interior, 36 less than 2 times the measure. I said 2x minus 36. So I knew these were supplementary. So I set them equal to 180, solved, and got that x equals 72, which meant that the exterior angle was 72 and the interior was 108. I didn't actually need to find that though, because if I know that each exterior angle in a regular polygon or equilateral is 72, I would take 360 total degrees divided by 72 and got that to be 5 or 5 sides, which means that I have a regular pentagon here. So guys, in summary, after these 3 videos, we have a few major formulas. To find the sum of the interior angles of any polygon, it is the sides minus 2 times 180 degrees. To find the total diagonals in any polygon, it is n times n minus 3. Let me try that again. It is, repeat that, n times n minus 3 all over 2. The total exterior angles in any polygon, no matter what, is 360 total degrees. And for a regular polygon only, if I would like to find each exterior angle, it is 360 divided by the number of sides, or if I have the sides, it is 360 degrees divided by each exterior angle. And remember, the reason this one only works for regular polygons is because you are assuming that each angle is the same measurement, and that is not true if your figure is not equal angular. So there's a summary. Yes, this information will be on the final exam, but no, we will not be having an official quiz over this material. When you get back from break on Tuesday, I am planning to do a day of practice of this. And I do have a practice quiz prepared, meaning something that we'll probably do in class and you'll grade yourself so you can see how you would do on a testing situation. But we do not have time to actually test this. So the reason I wanted to make these videos is so that you can go back and watch them as many times as you'd like. In fact, I'm going to post the notes, a blank copy, on my website. So if you want to print out another copy and try these out on your own, that is a great way to study. If not now, then right before the final would be a good time. These formulas will not be provided for you on the final, so you need to know them, as well as other formulas such as distance formula, midpoint formula, point slope form, standard form, slope intercept. So start preparing yourself for that. Thank you so much, guys, for tuning in. I hope these videos were helpful. I'd love some feedback when you get back on Tuesday. Yeah, I hope you're having a wonderful break, and I will see you guys in 2017. Thank you.